Today's lesson is on solution stoichiometry, so it's just like the stoichiometry that we looked at in the last unit. In the last unit, we were always trying to calculate the amount or the mass of a product or reactant. So what we're going to be doing with solution stoichiometry is that we're going to have concentrations involved in our calculations. So just like in our last unit for gravimetric stoichiometry, we were trying to figure out a way to get the mass to moles, so that if you know the moles of one compound in the chemical reaction equation here, you can use mole ratios to figure out the moles of another substance in the chemical reaction. Okay, so that's still our goal. We're trying to get to moles, and then instead of trying to find the mass in the end, we're going to be finding the concentration. So just as a review, this is what you did last unit, right? So you would have a balanced chemical equation. You would start off with mass. So then, using our, molar mass and so forth, we would bounce between, get to the moles island here. Okay, and then from here we do the mole ratio to figure out the moles of the substance we don't know or that we're trying to find. And then we would go up here and then use molar mass again in order to find mass. Okay, so we're going to do the same kind of box method here, but instead of trying to find mass, we're going to try to find the concentration or the volume and so forth. Okay, so again, just a reminder, we learned about amount concentration already in this unit. So here was the formula. So it was the amount in moles divided by a volume in liters. Okay, so there is a way, if you rearrange this, like we move this over here, we can end up with a formula that can calculate the amount in moles. So that's what we're going to do today. We're going to get to moles and then find the moles of the other one, and then find the concentration of the one that we need to find. Okay, so again, it's very similar to what you did before. So if you had a good grasp of gravimetric stoichiometry, you should be able to breeze through this. But again, if you were a little bit shaky with it, maybe seeing it again for the second time will kind of build your confidence. Okay, we'll jump right into an example here. So we have a balanced chemical equation here. These are all solutions. So these would have aqueous as their state symbols, except water would be liquid. And then this would be aqueous as well. So what we're looking at here is so we have 10 milliliters of hydrogen sulfate here. And it reacts completely with 15.9 mils of potassium hydroxide. Okay, and we happen to know the concentration of potassium hydroxide. So I want to know, like, if you know this information here, can you tell me what the molar concentration, or again, amount concentration of hydrogen sulfate here? Okay, so I just copied the balanced chemical equation again right here, so I can write the information that I know and the information that I need to find. Okay, so this is like the given and required step of a grasp. So right now we know that it's 10 milliliters of the hydrogen sulfate here. So 10 milliliters. So actually, sorry. So we know milliliters is volume. Okay, so we know the volume of hydrogen sulfate is 10 milliliters. Okay, and then we know that it reacts completely with 15 milliliters of potassium hydroxide here. And we know the concentration of potassium hydroxide. So I'm using V and C to represent those values. Okay, all right, so in the end, so that's what's given to you, right? And what's required is this here. So we want to find the molar concentration of sulfuric acid here, or hydrogen sulfate, okay? All right, so that's what we have to find, that's our goal. All right, so this is the plan. Okay, so this is the plan. So you know information about potassium hydroxide. So that's what you're going to use in order to find the amount in moles. And then you're going to use mole ratio to figure out the amount of hydrogen sulfate, and then eventually get to the concentration. So here's our plan. So we use the box method. So you're going to start with, so you know the concentration. Okay, so you know the concentration of potassium hydroxide. Okay, so then you're going to go to the moles of potassium hydroxide. Okay, so again, we're going to use the formula that we had up here. So we're going to use N equals CV, okay, to get to the moles of potassium hydroxide. And again, we could do that because we do have the concentration and the volume, okay? All right, and then we're going to go across. Remember, this step here is the mole ratio step. So here, maybe I'll use different colors. That's what I did last unit. So here, this is the N equals CV step. This is the mole ratio step. Okay, and then so once we do the mole ratio, we'll figure out the moles of the unknown, which is hydrogen sulfate. Okay, all right, and then once we get to the moles, we can go to the concentration, which is right there. Okay, so I'll just write it again anyway. So our plan is separate from our given and required steps. Okay, so, and again, to get from here to here, to find concentration, we need this formula right here. Okay, so let's write that in. So we're going to have C equals N over V. Okay, like that. All right, so so again, so I know it was kind of 50-50. A lot of you like to use the formula method. A lot of you like to use the unit analysis method. So again, you can still kind of use, you can use both here again. So just continue with whatever you felt comfortable with, or again, give the other method a try in this unit, okay? If you feel pretty confident with the one method. All right, so that's the plan. So now we're gonna go through and yeah, just actually put the plan into action here. Okay, so step one, so like this was the first step, this is the second step, and this is the third step. So I'm going to use the formula method first, okay? And then I'll use the unit analysis method. Okay, so step one, what you're doing here is you need to work with concentration and volume and so forth in order to get moles. Okay, so one thing here is, remember back when we did amount concentration, the volume had to be in liters. Okay, so let's make that change right now. So yeah, let's change it here. Okay, so we need to change this to liters. So we're gonna divide by 1,000. Okay, and oh, this one too. And then just carry all the digits there. Okay, so 159, 0.0159. Okay, all right, so so now we have everything in liters, we're good. You know, the units per amount, concentration, and mole per liter, that's good. Okay, so step one, we are going to go through this first step here. So we're gonna find the amount of potassium hydroxide. Okay, all right, so in order to do that, we need to use this formula here. Okay, so we'll fill it in. So the concentration was 0.15 mole per liter. Okay, and we're multiplying by the volume, which has now been converted to liters. All right, and then we're going to multiply those out. And we get so my calculator is giving me scientific notation, but I'll write it out. Not in scientific notation for you guys. Okay, but yeah, if you wrote it in scientific notation, it's fine. 1, 2, 3 spots. Okay, 2, 3, 5. Okay, so there we go. And then the liters will cancel out here. Okay, so that leaves me moles. Okay, which is what I want because it's amount that we just found. Okay, all right, so amount is done. Step one is done. Okay, step two, now we're going to use the mole ratio. Okay, so what is it that we have? We have potassium hydroxide. What is it that we need to find? We need sulfuric acid. Okay, so what's the ratio in the balanced chemical equation? So make sure it's balanced. So it's 2 to 1, 2 to 1. Okay, so 2 to 1. So if we know the amount of potassium hydroxide, what we're going to be doing here is we're going to be going this way here. We're going to find the amount of sulfuric acid, so we have to divide by 2. Okay, so we squeezed it in here. So it's a 2-to-1 ratio. So when we're going from our known to our unknown, we are having to divide by 2, right? We're going to half of what we had before. So we're taking the amount of potassium hydroxide, and so we're dividing it by 2. So this will now be the amount of the sulfuric acid. Okay. All right. So let's squeeze it in right here. Okay. So this is like step 1. So this is step 1. This is step 2. Okay. We're going to squeeze in step 3 right here. Okay. Okay, so that's the last step of the box here. Okay, so the last step of the box here. So now that we have the amount of sulfuric acid, we're going to go up and find the concentration, because that's what we need to find, of sulfuric acid. So we're going to use the C equals N over V formula. Okay, so now we're at the concentration of sulfuric acid. Okay, so we need C equals N over V. So we have our amount now. There it is. So again, make sure just carry it in your calculator. Don't clear it. So that way, oops, this is 1, 1. 1, 1, 9, 2, 5. Okay. All right, and then divide by. Okay, we're going to divide by. So if we go back to the original given information here, so remember the 10 milliliters, that's what it was for the sulfuric acid, okay? So, but then we are going to take the liters, okay, conversion here. All right, so take that, divide by 0.01, okay, and we get a concentration of 925 mole per liter. Okay, so there's our concentration of sulfuric acid, and then I'm just going to figure out what to round here. So we got 2 there, 2 there. Okay, so round to 2 digits. Like that. Okay, and then make a therefore statement now. Okay, so therefore the concentration, so the molar concentration of sulfuric acid is 0.12 mole per liter. Okay, got it squeezed in there. All right, that was the formula method now. Okay, so again, both methods work on just the whole idea of you should know that you should be doing this, and then switching it to here, and then switching it to there. Okay, so again, recommend draw this out so you kind of have your plan set out so you know you're not forgetting anything. Okay. All right, so now that we're there, so hopefully you can see that it's very similar to what we did before, but last time you used N equals M over capital M, right, to get to mass and so forth. But now we're just using a different formula in these 2 sections here, okay? But the mole ratio part is still the same. All right, so I'm going to show you how to do this with unit analysis now. Just grabbed example 1 again, grabbed all the information, the given, the required, and our plan here, okay? But we're going to use the unit analysis method instead. Okay, so we're going to start off with our, so we need to find the concentration of sulfuric acid here. Okay, so we're going to start off with the concentration of potassium hydroxide here. So we know it's 0.15 mole per liter. Okay, so that's a potassium hydroxide, and then we are going to use our volume in order to get it to the amount. Okay, so again, you have to make a decision which way will you stack the volume. So you don't want the liters to be together, so you want to put the liters at the top. So you're going to multiply, and again by the liters conversion here. Okay, so you can think of this is now completed the first step here. Okay, the next step now that we need to add here is the mole ratio step. So Again, we're going to put um, the uh, the moles of the thing that we need to find. So sulfuric acid at the top. So we have one of those. So it's 1 mole of sulfuric acid, okay, over comparing with 2 moles of potassium hydroxide. Okay, so the one we know always goes to the bottom, the one we need to find goes to the top. Okay, and then from there, we go to the last step here. We need to use our, so because if you look at all the units right now, so this cancels, right? The moles of potassium hydroxide cancels, so now you just have moles left. So in order to get to concentration, we need to use the volume of the unknown. So again, you need to use this volume value here. You need to figure out which way it goes. Well, mole's already here. You need to have it liters, mole per liter. So we need to have the 10 milliliters, which is in liters now, at the bottom like that. Okay. All right. So from there, everything's canceled out except mole per liter, which is what we want. So we're going to go through and calculate that out. Okay, so multiply the 0.15 and the 0.0159, and then divide by 2 and this value here. Okay, and then we get to a concentration with a lot less writing of 0.11925 mole per liter. Okay, and again, we're going to round to 2 digits here, or just keep 2 significant digits, right, and make our therefore statement. Okay, so the key is make sure write the keyword. A lot of you are still not doing it. Okay, sorry, the molar concentration of sulfuric acid is 0.12 mole per liter, and then don't forget the units as well. Okay, we'll do one more example because I feel like if you understood how to do gravimetric stoichiometry from the last unit, just seeing a couple more examples to refresh should be good. If not, just email me if you guys want to see more examples with solution stoichiometry, okay? All right, so this is kind of like an ultimate type question that you should be able to do now that you are kind of towards the end of Chemistry 11. So because we've been practicing our nomenclature and practicing balancing equations and so forth, you should be able to take a statement like this and translate it into a balanced chemical equation, okay? All right, so we have sulfuric acid here reacts with sodium hydroxide and it produces water and sodium sulfate. Okay, we know the volume of sulfuric acid is this, oh not the, sorry, we know the, okay, we need to find the volume of sulfuric acid knowing the concentration, because I know M means it's the same as mole per liter. Okay, so M is the same as mole per liter. Okay, so just it's a way that chemists write mole per liter, just kind of more simplified form. So we need to know what volume is required to react completely with 75 milliliters of 0.5 mole per liter sodium hydroxide. Okay, all right, so let's start off with writing the balanced chemical equation here. So we have sulfuric acid, okay, reacts with sodium hydroxide, okay, and it produces water and sodium sulfate. Okay, so again, if you're trying to translate this one, it's sodium, it takes a +1 charge, sulfate, right, is SO4, -2. So when you balance all the charges and so forth, or crisscross, you get sodium sulfate like that. Okay, all right, and again, if you want to practice your state symbols, so we know we have a reaction here. This is aqueous, acids are aqueous, bases are aqueous, water is that pure substance, so we write liquids, and then sodium sulfate, if you look at your solubility table, sulfates, so again, if you want to look at your solubility table, sulfates are soluble with sodium, okay? So, and we remember any kind of group 1 metals are always soluble. So, all right, so this is aqueous as well. Okay, so and then the next step here is to have a balanced chemical equation before we start actually going through the stoichiometry part of this problem. So again, it doesn't matter which one you start with. I guess I'll start with sodium. So we have 2 sodiums here, so we need 2 on this side. Okay, 2 on this side. All right, and then let's see how many hydrogens. We have 2 here, and then we have 2 here, so that's 4 on this side. So we have only 2 here, so I'm going to put another 2, whoops, here, and then get 2 in front here. So now I have 4 hydrogens, 4 hydrogens, 2 sodiums, 2 sodiums. Okay, so let's see the sulfurs. I have 1 sulfur here, 1 sulfur there. That's okay. So now let's count the oxygens. I have 4 here. I have 2 more. That's 6 on this left side, 4 here, and then 2 here. So 6 on that side. So now it's nice and balanced up. Okay, so again, whatever way that you can get it to balance. I know a lot of you still like to write out the elements and tally them up and so forth, but just make sure it's correct. Okay. All right, so then from there, let's write down everything that's given to us and everything what's required, okay? So what's given to us? So we have 2 molar of sulfuric acid. So we actually know the concentration of sulfuric acid. Okay, so it's 2 molar like that, but it is the same as writing it like this. Okay, mole per liter. All right, so again, like chemists will like to write mole per liter like this, and they'll just say 2 molar, 2 molar. It's just kind of a short way. It's like a slang way, I guess, of saying the amount concentration. Okay, all right. So just get comfortable with it so that you're not thrown off guard when you see that somewhere else. Okay, so then we have the concentration. So then we're reacting completely with concentration of sodium hydroxide here of 0.50 mole per liter. Okay, and we have a volume of sodium hydroxide. It's 75 milliliters, and again, right away, I'm going to convert that to liters. Okay, by dividing by 1,000. Okay, so that's what's given to you. So what is required? What is it that you need to find? I'm just going to write it in red here. It says what volume of sulfuric acid is required. Okay, so we need to find the volume of sulfuric acid this time. Okay, so again, the last question when you had to find the concentration, here you just have to get to the volume. Okay, all right, so here's our plan. So we're going to use a little box here to make our plan. So we know the concentration of sodium hydroxide right now. We're going to use that to get to the amount of sodium hydroxide, because again, we need to get to amount in moles in order to make a comparison and to find some more information about the rest of the chemical reaction. All right, and then from there, we're going to get to the amount of sulfuric acid, okay, using mole ratio, and so I'll write all that stuff in a sec. And then in this case here, we need to get to the volume of sulfuric acid. Okay, so just a little adjustment to the formula that we use here. Okay, so let's look at what we need to do here. So in the first step here, going from the concentration to the amount, so we know that, so again, if we write the formulas out here, we know this formula, we can rearrange it to get to amount by taking concentration times the, volume here. Okay, so in order to get to amount, we're going to take the concentration multiplied by the volume. Now we have the amount. Okay, so then from there, we're going to use the mole ratio. And we can do that because we have our balanced chemical equation here. All right, and then once we get to here, so again, we need to get to volume. So using these formulas here, how do we solve for volume? Well, volume is amount divided by concentration. So again, you're just booting this over here. So you're rearranging it. I noticed that some of you did have this formula written out. So it's kind of like the density formula. So yeah, that's fine as well. So if you prefer to use that formula, okay? So this way, if you're trying to find concentration, you know, it's the amount divided by volume, or if you're trying to find the amount, you need to take concentration times volume, or if you're trying to find volume, you're trying to take the amount divided by concentration. Okay, so again, it's good to be able to rearrange stuff, but if having these visuals too, that works, then that's fine as well. Okay, so we're just going to write that in here to remind ourselves so that when we have to do that last step, this is what we're doing. We're taking the amount and we're dividing by the concentration. Okay, so again, I'm going to do the formula method first, and then I will do the unit analysis after. Okay, so I know it bothered some people that I was doing both, so again, yeah, just I don't know, skip this part if you're not a formula person, okay? And just go to the unit analysis part of the video. So formula method here. Okay, so step one, I'm going to find the amount of sodium hydroxide. Okay, so I'm going to use N equals C times V here. So we have concentration of sodium hydroxide was 0.50 mole per liter, and the volume was 75 milliliters, but we converted it to liters. Okay, and we'll calculate that out. And we'll get to this amount, okay, so in moles. All right, so we have the amount in moles for sodium hydroxide, so now we're going to go and use the mole ratio here. So in order to find the amount of sulfuric acid, we're going to use the mole ratio here. Okay, so the amount that we know is sodium hydroxide. The amount that we're trying to find is sulfuric acid. All right, so go back to the balanced chemical equation here. So it is a 2-to-1 ratio here. So 2 to 1. So again, you're dividing by 2. So if you start with, this is the amount of sodium hydroxide, you're going to divide it by 2 in order to get to the amount of sulfuric acid. And there it is. Okay, all right, and then our last step here is now we're going up and we need to find the volume this time. So here, let's squeeze that in over here. Okay, we're going to run out of space. All right, so step 3, we're going to find the volume of sulfuric acid. Okay, and the formula is to take the amount and divide by the concentration. Okay, so the amount we found here from the mole ratio and then we're going to divide by the concentration. Okay, so again, you're like, where's the concentration of sulfuric acid? So it was given to you here, remember the 2 molar. Okay, so we're just going to write divide by 2 mole per liter here. All right, and that leaves us with a volume of 1, 2, 3. Okay, and so that in liters. And so let's see what sig figs we need here. So we have 2 digits here, we have 2 digits here, 2 digits there. So we need this to be in 2 digits. So it's kind of a tiny number, so I'm going to convert it to scientific notation. But if you wrote it like this, it's fine, okay? But just let's practice everything we learned this year. So you can go 9.4 like that times 10 to the -3 liters as well as acceptable as well. Okay, so here is our final statement now. So therefore, the volume of sulfuric acid is 9.4 times 10 to the -3 liters, like that. Okay, so now we'll try the unit analysis method. But again, if you're ready to move on and do some practice questions, again, just go through the steps of find the given, find what's required, set up your plan here, and then go through the steps and calculate out. So again, setting up your plan is really important because you can kind of organize what you need to do at each step. Okay, so last time we had to find concentration, this time we had to find volume, so we had to change our formula here. Okay, so again, if it helps to use a triangle, do that, or if you know how to convert and move around equations, do that as well. I had lied. I do have actually a couple more examples after this one. So if you needed to see extra ones, then yeah, just keep watching the video. But after this example, if you're like, okay, I get this. This is very straightforward. It's similar to what we did last unit. Then yeah, feel free to just go and practice on your own and try the checkpoint. Okay. All right. So for this one here, we are again just practicing the unit analysis method now. Okay, so we need to find the volume of sulfuric acid. Okay, so we're going to start off with our concentration of our known sodium hydroxide. Okay, all right, so in our first branch here, so we need to get to the amount by using so just by using the volume that we're given. So we know that there is 75 milliliters of sodium hydroxide, so we just got to decide which way do we stack that. Oh, we should put it up at the top because we don't want the same units to be on the same level here. Okay, so we need to multiply that. All right, so the next step here is this branch here, the mole ratio. So again, the unknown always goes to the top, so that's sulfuric acid, so that's 1 to 2 here, okay? So 1 mole of sulfuric acid, okay, to 2 moles of the known, which is sodium hydroxide. Okay, so we're good there. All right, and then so the last step here is now so we need to get to volume. So right now we have, so if we cancel everything out here, we have volume, the liters are gone here, the amount of sodium hydroxide is gone. So we have the amount for sulfuric acid. Okay, so we need to use now the concentration, which is the last value here, and we need to decide which way are we going to stack this. Okay, so right now we have moles, we need to get to liters. So this is a mole per liter unit. So again, if I stack it like this, see how the moles will clash? So that's not going to work. So I'm going to stack it the other way so that the liters are at the top and the moles are at the bottom. Okay, so that's 2 mole per liter. Okay, 2 mole per liter, and again, this is of sulfuric acid, right? All right, so and then so then you end up with 2 over 1 like that. Okay, and so that will cancel out as well, and that's the right way. So that's how you double check that everything's in the right spot, everything's been flipped the right way, and this way you're not memorizing any formulas. Okay, all right, so let's go through, calculate everything at the top. Okay, 0.5, 0.075, okay, it equals, and then we're going to divide by 2 times 2 here, so divide by 4, and we end up with a volume of the same volume that we had before, and then we need 2 digits here. So you can do that, or just change it to scientific notation. It's better this way. So again, because if you're communicating this with another scientist and so forth, you don't want to lose zeros and so forth here, okay? All right, so 9.4 times 10 to the negative 3 liters, okay? And write your therefore statement. Okay, so yes, there's another example here. Sorry, the volume of the sulfuric acid, there we go, 9.4 times 10 to the negative 3 liters. Okay, so here's another example, but again, if you don't need to see another example, just stop the video and go and practice, okay? Here, we'll just carry on here. So example 3, we have how many moles of iron 3 hydroxide are produced when 85.0 liters of iron 3 sulfate at a concentration of 0.6 there reacts with an excess of sodium hydroxide. Okay, so a lot of stuff going on here, and again we have to build the balanced chemical equation. So we're trying to figure out how much of this is produced. So that means the iron 3, so this is iron 3, okay, and this is sulfate. So we gotta make that compound, iron 3 sulfate, so that will be, so the 2 comes here and the sulfate gets the 3. Okay, so iron 3 sulfate reacts with an excess of sodium hydroxide. Okay, we know that iron 3 hydroxide is formed. Okay, so hopefully you can recognize that this is a double displacement reaction. So the metals will swap places, swap partners. So iron takes hydroxide, so that means the sodium, okay, so again, sodium will grab the sulfate. So that means we have like a sodium and sulfate to combine together, okay? So let's get the formula correct here. And we get sodium sulfate like that. Okay, so yeah, and so now let's write the state symbols here. So sulfate iron is okay there, so that's aqueous. Sodium hydroxide aqueous, and then iron 3 hydroxide here. Okay, so that one's aqueous, and anything with sodium is aqueous. Okay, so we have all of our aqueous state symbols here, and then I'm just going to go and balance. So there's 2 irons here, 2 there. I have 3 sulfates here, so I'll put a 3 in front here. Okay, so the sulfates are balanced. Remember the polyatomics, take it as a bunch here. Okay, so there's 3 sulfates, so now I put a 3 here, 3 sulfates. All right, sodium, now I have 6, so I'll put a 6 here. And okay, so that leaves hydroxide. There's 6 hydroxides now. Take a look here. Yep, 6 hydroxides, so we're nice and balanced here. Okay, last example. So we have a technician dissolves 17.1 grams of aluminum sulfate to make a solution. What amount, concentration of aluminum ions and sulfate ions are there in the solution? Okay, so all we're doing is this a dissociation equation? So we have aluminum sulfate here. Okay, and we're just dissociating it, so we're just dissolving it in water. So, so we have a dissociation equation, so we're just going to have an equation here with the ions, okay? So this is what aluminum would be as an ion and sulfate as an ion. So again, these are all aqueous. Okay, and so, but with the dissociation equation, just like the other reaction equations, you can balance it, okay? So see how we have 2 aluminums here, so we need 2 here, and see how the sulfates, we have 3 of them, so we're going to write 3 here, so then it balances out. Okay, so now that we have our balanced chemical equation, let's write down what's given to us here. Okay. So let's see here, we need to find the moles of, so I can even write that down. We need to find the amount of iron 3 hydroxide. Okay, so that's different from the other ones. So we need to find the amount. When we know the 85 liters of iron 3 sulfate, okay, so we're already in liters, so that's good. We don't have to convert that. And at a concentration of and with an excess, so this is excess, okay? All right, so we know that this, because this is the excess, we know this is the limiting reagent. This is going to control the amount of everything in the reaction, okay? Okay, so now that we know what's given, we need to find this. That's what's required. Okay, so we need to find the amount of iron 3 hydroxide. Okay, so our plan here is, again, we are going from this one here. So we are going to start with our concentration of iron 3 sulfate. Okay, and we're going to get to the amount of iron 3 sulfate. All right, then once we know the amount, we can find the amount of iron 3 hydroxide. And that's as far as this question wants us to go. We don't need to go and find, the volume or the concentration or anything like that. Okay, so so we're going to figure out how many moles of iron 3 hydroxide are produced. Okay, so just 2 steps here. All right, so and then just to fill in the rest of our plan here. So in order to go from concentration to amount, we're going to take concentration and multiply by the volume. And then to get to the amount in moles of the unknown here, we're going to use mole ratio. Okay, so step 1, let's find the amount of iron 3 sulfate here. Okay, so by using this formula here. Okay, so the concentration here is 0.6 mole per liter, okay, multiplied by the 85 liters. Okay, and that's 51 moles. Okay, all right, and from there, we need to find the amount of the unknown, which is iron 3 hydroxide. Okay, so we're going to do that using the mole ratio. So again, we know this one here. It's a lot to write with this formula here. Okay, and iron 3 hydroxide. Okay, so if we look at the balanced chemical equation here, so iron 3 sulfate compared to iron 3 hydroxide, it's a 1:2 ratio. So 1:2. So what we're going to do is we're going to double now to get to the amount of iron 3 hydroxide. Okay, so we have 51 moles right now. So if we're going to double that, we are going to end up with 102 moles. Okay, all right, and and then we just stopped there because that's all it wanted. It wanted to know the amount of iron 3 hydroxide. Is 102 moles. Okay, and actually let's look at the sig figs here. So we have 3 digits, 3 digits. Oh, perfect, 3 digits. Okay, so our answer is 3 digits. Okay, and yeah, that's it. Okay, so this was the formula method here. So I'm going to do the unit analysis. I'm going to squeeze it in right in so I'd hear it. Okay, so we're going to start, well, we need to find the amount of iron 3 hydroxide. So we're going to start with the concentration. Okay, of the iron 3 sulfate. Okay, and then we're going to use the volume. So basically, so when we have volume, we don't want it at the bottom, we want it at the top. Okay, And then we need to use the mole ratio, which is 1 to 2. Sorry, the 2 to 1, I guess, because the one we need to find is 2. And the one we do know is 1. Just squeezing this in here. All right, and then we just stop there because that's all we need to find here. So the liters will cancel out, the moles will cancel out, and then it leaves moles, which is what we want, okay? So when we go through 0.6 times 85 times 2 at the top, divided by just 1 at the bottom, you end up with 102 moles, like that, okay? And then you just write your final statement. Okay, so we know that there's a mass of aluminum sulfate here of 17.6 grams, oops, or 1 gram, sorry, 17.1 grams, and we need to prepare a solution of 250 milliliters, okay? So in the end, we need to find the concentration of aluminum and the concentration of the sulfate ions. Okay, so even though it's a dissociation equation, you would still just go through it the same as you would when it was a chemical reaction equation, right? Where you actually have other compounds on the other side and so forth. Okay, so that's what's given to you. Okay, we looked at what's required. These are required. Okay, so the required step is done. Okay, there and there. Okay, and so here's our plan. Our goal here is to try to get to the concentration of these ions here. So if we can find the concentration of the aluminum sulfate, you can use the mole ratio to find the concentration of these ions here, okay? So we're going to start with mass here, and then so in order to get to concentration, if you have mass, is that you have to get to amount of moles, and then once you get to amount of moles, you can use the volume to get to concentration, okay? So here's the plan. So you're going to go from, the mass island. Oops. So you're going to go to the mass island here, okay, and jump to the moles island, okay, and then get to concentration. So that's the plan. Okay, all right, so let's, maybe draw the box method as well here. So we have the mass of aluminum sulfate. Okay, so we're going to get to the amount. Okay, and then we're going to get to the concentration. So it's almost like there's a few sides to this one side of the box, okay? All right, so then we can go across and use the mole ratio in order to get the concentration of aluminum and of sulfate. Okay, so the same, because, this is a dissociation equation here. So if you know the concentration of this, you can use the mole ratio to figure out the concentration of these here, okay? All right, so let's just go through and put our plan into action here. Okay, so again, if we wanted to just write our formulas in here to get to amount, remember it's this one from back in last unit. That's how you get to the amount. Okay, so you need the molar mass, which we'll do in a sec. And then to get from amount to concentration, you need to take amount and divide it by volume, which we have volume, okay? And then from there, you're going to use the mole ratio. Okay, so let's go and do that now. Okay, so the first step is to get to the amount of aluminum sulfate here. So we're going to use the formula mass divided by molar mass. So again, I did the molar mass here. It's a little bit tricky. So you have 2 aluminums, you have 3 sulfates, and then you have 12 oxygens. Okay. All right. So the mass that we were given here was 17.1 grams of aluminum sulfate divided by the molar mass. And we end up with an amount of, okay, and there's more digits, just keep it in your calculator. Okay, so that's the first step. We got it to amount. Now we need to go to concentration. So the concentration formula is the amount divided by the volume. And the volume was 250 milliliters. Okay, so let's change that to liters. Okay, I'm carrying all the digits. There's 4 digits here. Okay, and let's divide that out. And you end up with a concentration of, I'm just going to carry all the digits here. Okay, so mole per liter, like that. Okay, so we know the concentration of aluminum sulfate. So now we're going to use the mole ratio in order to figure out the concentration of the ions there. Okay, so we're going to start with the first one, just the aluminum. Okay, so aluminum sulfate compared to the aluminum ion is a 1:2 ratio. Okay, so again, going from 1 to 2. So that means we have to multiply the amount, the concentration that we have here. Okay, so if we do that, we're going to get, so from 1999, like that, mole per liter, to when you double it, 1, etc., mole per liter, like that. Okay. All right, so that's that one. And we also do a comparison with the sulfate ion. It was a 1:3 ratio. So we need to triple it. Okay, so again, the 0.1119 mole per liter. Okay, when we compare it, it should be tripled. Mole per liter, like that. Okay, all right, and so then what are the amount concentrations for both of those? Make a therefore statement. Therefore. Okay, so the amount concentration for the aluminum ions are, let's look at how many to round to here. So 4 digits here, 3 digits there. So we need just 3 digits, which is going to be a little tricky here. So 3 digits, so we just have to, I guess, go to 4 when we round it up, okay? So for aluminum, for that, and for sulfate, ions, and again, rounding it up, but carry all the digits. So we have 3 significant digits. Okay, so the amount concentration of aluminum ions is 0.4 and 0.6 mole per liter.